Hi, it's Jan Beta, and there's one Commodore computer I haven't covered at all on this channel. There are several actually, but this one is quite obvious. It's the C16, and I haven't covered it yet, so I just bought one. Which actually has been sitting around here for quite some time. And I haven't done any work on this yet. And then there was Chris, who donated this one. That you saw, if you are a patron of my channel, you saw me unbox this. And he also donated another one. And then recently, Wolfgang from Germany contacted me and donated this one, which has a 64K mod in it, with like a RAM expansion mod. So I now have 4 C16s that are all absolutely and utterly non-functional. Which isn't very rare with these, because they have a couple of chips that fail very frequently. So what I'm going to do today is to go through these 4 C16s and see if I can get one to work at least. Hopefully I can get all of them to work at some point, but I hope today the plan is to get one to work properly. So let's get right into it! So let's just start with the one that I bought myself a while ago. It was part of I think it was part of the eBay lot that I bought when I got the Aldi C64 that I refurbished. I think it came with one of the Aldi C64s that I bought. I bought like 3 Aldi C64s and fixed 2 of them. And one is still in a state of unfixability, kind of, sort of thing. Still working on that. Updates soonish. So, yeah, let's just open this up. This is like a... I think this is one of the reasons why Commodore went bankrupt in the end. Was like a misconception of the idea of the 264 series that was designed, very cleverly designed, by Bill Hurd, most prominently, and a team of engineers, obviously, that it was meant to be like a cheap office PC computer, and it was not meant to compete with the C64, which was still very popular at the time. So they designed like the Plus 4, which is a much smaller computer, and they designed like the C116, which is also a smaller one with a rubber keyboard, which was meant to compete against the Sinclair ZX Spectrum at the time. And they also designed a bigger series of 264s and also a 364 that never made it to market. Then management said, wow, we have this new computer that hasn't got the graphics and sound capabilities that the Commodore 64 has, but it seems like a proper computer at first glance, and you can do quite some serious work with it. Also, it has a better BASIC. So we're going to market it as like a new 64. And they decided to put it in this case, which is like basically the Commodore 64 case in black. And they put the Commodore 64 keyboard in gray in there. And yeah, basically, as you're going to see, this is not the case that these computers were designed for. So let's open this up and have a look. And also they sold it for much more than the designers intended. So here we are. I took this apart previously. There's the one key that is missing from the front. It's still in there, but the stem is broken, so I have to replace that. But I have replacements. I can like salvage that from a C64 mainboard, I guess. So there we are. This is the small main PCB that's in these machines. And yeah, the thing is, the original machines this was designed for are like this form factor. They are much smaller than the case this was released in. So yeah, as you can see, this wasn't made for this. This is just a hack job made from the C64 case, or the VIC-20 case, which was basically reused for the C64. And then they put it into this form factor. So yeah, not a very good decision in my opinion. Let's see if we can get this to work. First problem, the power supply. The C16 uses 9 volts DC at, I think, 1.5 amps or something thereabouts. The original power supply is, I think it's underpowered for the machine, so the original power supply basically is unusable. It's the same crap design as the C64 power bricks, so it's not recommended using the original power supply. I have one somewhere, maybe I'm going to show it. I bought this, which is a meanwhile like 2 amps, 9 volts power supply that has, like the C16, it has a standard barrel plug, which is the same you find on the ZX Spectrum, the Sega Mega Drive, the, you name it, the Super Nintendo, the original Nintendo Entertainment System. They all have the same format, size of barrel plug. And so does the C16. These systems all share another thing, which is that they are all center negative. Nowadays, most of these modern power supplies are center positive. So that means the little hole in the middle of the plug is the positive connection, and the outer shell is the negative connection, or the ground. And as you can see, I marked this and I changed the polarity of the plug basically. I just cut it and soldered the wires on the opposite polarity, and I made a little sticker to show you that this is a center negative supply now, which is what we need for these. I think a couple of these, or many of these, actually died because people got the polarity wrong, as many ZX Spectrums did as well and stuff like that. So let's see what happened to this one. So I want to get the board out at first. I think I'm using my wrist strap. There's a lot of cables on the little bench here. So let's get these out of here. This is screwed down pretty thoroughly. And there's not the original screws in here. That means somebody had a go at this already. So I hope we can save this. So this should not come out. Yes, it does. Okay, there we are. Let's connect some power, and I think I want to get some voltages first. There's a 7805 voltage regulator in there that provides the ICs with power. What usually breaks on these is the processor, the 8501, or the TED, which is the integrated, it's like the graphics and the sound chip in one chip. The ROMs are usually okay. And there's what's also there. There's also some RAM, of course, 16 kilobytes, which you can actually up to 64 kilobytes. There's like 44 16 chips in here, and you can insert 44 64s, I think, and make some botch wires, and then this machine has 64 kilobytes. Because the architecture was designed to have more memory, and they just, this is the cheapest version of it that was like cut down to 16 kilobytes of memory. So, okay, without further ado, let's just try to power this on. The video out is the same as on the C64, so you can just use the cable I have. Like kind of installed permanently on my bench here, because I'm working on C64s a lot, as you probably know if you know the channel. Can we at least get something? Let's get some voltages first, I guess. So with the machine powered up, I should be able to put my ground somewhere on the metal part and get 5 volts here on the voltage regulator. Let's see if that happens. So we get 5 volts. We should get 9 volts input, I think. Yes, pretty close to 9 volts. Alright. So the supply voltage is good. So the processor gets 5 volts. That's cool. The TED So it seems that the TED gets the voltages from pin 4 and pin 24, VDD and VSS. So let's just check that. 5 volts, pin 24. There's nothing there. Okay, this gets warm, so that's probably alright. Processor gets warm too. The ROMs stay pretty cold. Yeah, as the processor is such a common failure, I just am going to, as I checked the voltages, so there's 5 volt supply on the processor as it's supposed to be. I'm just going to replace it with another one that I happen to have, which should be working. There we go. Okay, I think it probably just is the CPU. Because we get a kind of a video signal. Ah, come on. These are really cheap sockets, so yeah, might as well be that something doesn't make good contact or something on these. So there we go. Let's try again. Yep. Ta-da! Okay, broken processor. That was an easy fix. Okay, next. I'm going to fix the key later. That's none of my priorities now. So let's check the next one. So this is ones of the ones that Chris donated. Thank you very much. This has all the screws. That's a good sign. These came from the UK and this is made in England. So yeah. Let's see if this has the same issues. They are all dirty and... Oh, okay, the shield has been replaced. Has been removed, actually. Let's remove the keyboard for now. And give it a visual inspection. Reseat all the chips. It's a bit dusty. Okay, testing voltages at first, I guess. So same game as previously. Testing the voltage regulator and if the voltages actually reach the ICs. So this should be on. Should connect the power cable for this test, and we should also connect. We should test if it works at all. Maybe it just works. No, it doesn't. Okay, let's test some voltages. There should be 5 volts here, which there are. There should be 5 volts here, which there are. Okay. So this has 5 volts. Let's see if any of the chips get hot. Uh-oh. Okay, there's one thing that I probably maybe I did something stupid. Let's have a closer look. Maybe you can spot the fault I just spotted. So maybe you've seen this before I even turned this on. This chip is in the wrong orientation, so the little notch should be on this side. Like with these. This is the PLA, I believe. The PLA chip, basically. So this maybe burned out now. So let's just rotate it and see if that makes the machine power up. Otherwise, I suspect if you put a new PLA in there, it might just boot up. Let's see. I'm just cleaning these. These are the cheap sockets that have they're only single side grabs here. The next step would be double-sided, and the round precision sockets are the most expensive and I think the best, in my opinion. So okay, now this is in the proper orientation. Let's see if it does anything now. If that is broken, I hope that I didn't break it. I hope I wasn't the first person to power this on with the IC in the wrong orientation in there. Okay, we get some kind of video out. But no picture at all. Maybe it's the processor, maybe it's the PLA. Let's find out. Let's just put the processor in that we put in the last time, I guess. And see if that's the fault. That's the most common fault on these, so let's try that. Same procedure. Oh, this is a 7501 as well. This is the older, I believe, HMOS 1. The kind of manufacturing changed. So this is the older version. The 7501 is the older version. Okay, that might be the fix. Let's see. Yes. Okay. Another broken processor. Wow, okay, common fault gets a whole new meaning now. Another broken one. So, okay, that makes another broken 7501 in this case, which is the same as the 8501, but in a different manufacturing process. Wow, these are really not the best quality, it seems. So otherwise the machine seems to be perfectly okay. Next! Okay, here's the other one that Chris donated. Let's see if that has a similar fault. My guess is that it has the same fault. So let's open her up. Again, made in England. Which really doesn't mean anything, it just means they were assembled in England. And this is like the yellow silk screen going on there, it looks pretty nice, and the green is pretty colorful. Looks healthy, apart from the rust. It's pretty dusty as well. So let's just do the quick voltage test as well with this one. And see, yeah. Previously on Jan Beta. Okay, let's test the voltages. Again, we should test the input and the output voltages on the voltage regulator. Make sure the voltages get to the ICs. Okay, turning it on. Taking my ground from the metal part here. 5 volts on the voltage regulator. These are pretty sturdy usually. 5 volts on the processor. And 5 volts on the TAT chip. So maybe there's something wrong with the processor. Let's just pull it and see if the non-working one works. Oh, the socket is this is pretty crappy as well. Maybe there's something going on there. That might actually be the case. Maybe we'll try with the original processor first. Okay, let's try with this one after we clean it a bit. And that was the whole point. Okay. Nope. Nothing. And we get a little video flickers. That probably means that the text and graphics chip, music and graphics chip TAT is alright. So let's just try the processor that is known good. Okay, let's put in the good one. This way. Otherwise this one looks good. There's no chips in the wrong orientation or anything. Okay. Seating everything a bit. Wow, this really needs a cleaning, so... Okay. So my guess is this is going to power up now. Let's see. Okay. Nope. So this might have some other issues. I guess we should give this board a real good cleaning. Yeah, let's do that. Let's scrub the board and take it out of the case and then see. So what I could do now is to check the processor from this one in another board. Let's do that. So this is the previous one. Let's put the processor in here. Wow, there's quite some corrosion going on, so that's not... Maybe it's just... Yep, it's a good one. Nice. Okay, so we have two good processors. That's a good thing. Okay. So we already have one completely working C16. We have at least two, because we have two working processors and two boards that work. Nice. This is the other board again with the yellow silk screen. I want to replace or reseat all the ICs and just taking this out of the case here. Okay. Wow. Okay, there's broken off standoffs and clips from the case. We can probably fix this with Jeff Bird's C64 case savers. So he also has like replacement standoff things here. So we have at least two of them are missing in this one. Let's just flood this with some IPA and wash it off, I guess. Wow, this is even worse of a socket. Man, okay. Maybe it's just corrosion in the sockets here. So I'm going to place these in the order they're in the board, so I can put them back accordingly. Wow, okay, let's just put some IPA on it. And wash off the dirt. Hope I don't die of alcohol poisoning. Smells nice, actually. Let's go some more to wash it off. By the way, you can put these in a dishwasher, especially if you take off the ICs. But I don't have a dishwasher, so I can't really do that. That was a brilliant idea. I think I have to leave the room for a bit. I'll be right back. Okay, most of the alcohol has evaporated now. Let's get back to the board. And I'm just spraying some more contact cleaner in there for the chips to make better contact. Which in my experience is always a good idea with these cheap sockets, to make them at least make them work for a while. It's better to use proper sockets, and maybe it's worth replacing them with something better at some point. And the legs on the ROMs and the PLA are pretty clean actually. So processor I'm going to use this one, which is the spare one. Okay. Okay. Second try. Nothing. So it gives me a signal, but it doesn't start up. So it might also be the PLA, is my guess. Let's just replace that with a known working one. Or better still, let's take a known working system and put the chips from this one in there to test. Okay, so here's the known good one that we had previously. Outputs the startup screen, no problem. So let's just replace the chips. I suspect the PLA might be bad. There also might be, of course, there might be RAM issues and stuff. So let's just put the PLA in here. Let's see if that's bad, maybe. Okay, PLA. No, that's alright. So it gets a little okay. Okay, let's test the TAD. Ah. There we go. Okay, this one works. ROMs might be a problem too. ROMs would be easiest to replace because you can basically just put in EEPROMs, I think. Yep. Okay. So all the socketed chips are okay. So the socketed chips are okay, so it's probably maybe the RAM or something else. Yeah. Okay, we'll have to look into this board further at some point. But I just want to take a look at the last C16 we have, because it's an interesting one, because it has been modded. So let's have a look at that. At first, before I get into this board, this is the one that Wolfgang donated, and it has a little switch on the backside, which should be switching the memory expansion, I guess. Let's have a look inside. I have never looked inside this. Oh, the adventurous adventures. Oh, this is like not the original screws. These are not Phillips screws. Wow, okay, so I'm going to have to replace these. This is made in Germany, I guess. Made in Germany, yes. This came from Germany, this is made in Germany, interestingly. Wow, okay, this is like an older board, I guess, with the metal shield. Nice. So I've never seen one of these actually with the metal shield, which is pretty... Who would have thought they put so much effort into the C16? Interesting. It's from more civilized days. So and Wolfgang said that the fuse was blown in this one, so maybe somebody put in like a power supply with the wrong polarity or something. Might be. Wow, okay. Ah, there's wires soldered to the RAM, to like one of the logic chips and to the PLA, which is probably the way this works. Interesting. Okay, let's get some voltages and just do our normal procedures here. So, connecting this to power. I'm also connecting this to the screen. It's already turned on, okay. Oh, there's some things pulling too much current. Voltage just dropped down. Okay, so the regulator, it's a bit low. The input voltage is also a bit low. Okay, so something's broken. Oh, and one of this ROM here gets extremely hot. Okay, so this ROM gets extremely hot. That might just be the fault. Yeah, the other chips just get warm. If the voltage drops, by a little bit. It's a sign that something is shorted there. Yeah, so it might be this one got some overvoltage at some point and then broke the ROM. Which is pretty common actually with these old mask ROMs that MOS made. They are pretty, especially on older machines like the VIC-20, it's a pretty common fault actually. So let's just try one of the known good ones in this position. Let's test the voltage that gets there. Let's see if the voltage now stabilized without the ROM. It should just power the other chips like it should and just not be shorted. So the voltage should be closer to 5 volts again. It's always a good test to check for temperature. Still with modern parts, I guess. So let's see what this does now. Oh, it's still at 4.95, so it might have other issues as well. Maybe it has a wonky voltage regulator as well. Okay, so the TAT gets pretty odd too. But I suppose that's what it does. And we do get... I think we do get a little signal spike there. Okay, this gets too hot, I guess. Let's maybe remove that too. So this one at least looks very clean, so it's might be a good one. Let's see what the voltage says without the TAT. And so far we've only just used our finger to troubleshoot this basically, and a bit of knowledge. Okay, it's still not very good. Yeah. This mod seems to be pretty well done actually, so there's not much going on there. I think I want to just try and replace those two chips, or maybe try the TAT in a known working system first. I think I want to do that. I feel like I'm just wildly swapping chips around, which I wouldn't mind too much. Okay. Let's see if it works. So it doesn't work. And it just gets hot. So that's gone. Okay, so there's still nothing. But the chips don't get as hot. Maybe that's another processor issue there. Let's replace the processor, just because we can. Okay, let's try now. Nope. No, there seems to be more broken with this one, I guess. Yeah. Let's try if the processor works in the other board. My guess is that the processor also doesn't work, but we're going to see. Yeah, new. Okay. So we have multiple broken chips in the other one. So we at least have 2 working C16s now out of the 4 we had. And we have a bunch of broken ICs. So here's what we got. A broken processor, one broken ROM. I don't know which one it is, the basic or the kernel ROM. There's probably more broken chips in the one with the switchable memory expansion. Yeah, there's going to be more videos about this. There are ways to build an adapter for a 6510 processor, so you can use that in place of this, because it's just another variant of the 6502. And the 6510, which is the processor used in the Commodore 64, is pretty close to this. It has a slightly different pinout, so you can basically build an adapter to use the 6510, which Mr. Adrian Black did a while back. I'm gonna link his video in here. Pretty interesting thing. Yeah, it appears to be the CPU really is the problem in these. It's the main fault. The other one just had some serious overvoltage. And the other board I couldn't fix is, I believe, might have some RAM issues or something. We're going to look into that. So I ended up with two completely working C16s as of yet. One is going to be a refurbished video. This is going to stay here. This is going to be mine. It's got a key missing and stuff, and we got some interesting refurb work to do. This one is going to Sweden. I just gave it to Domedagspoeten, who is a fellow Twitch streamer. You can check out his channel. I'm going to link it below. You can check out my channel as well. I have a Twitch channel where I stream from real retro hardware. And he does that as well and is part of CommodoreStreamers.net, which I am part of too. So if you are interested in seeing people actually play games, new and old games on old hardware, on real hardware, check that site out. There's a bunch of really, really nice people, and I was it was a very warm welcome in the Twitch scene once I met those guys. So check those guys out. They're all worth following and watching, and I am hanging around in the chat frequently. So yeah, this goes to Sweden. He didn't want me to do any more work on this because he is like a tinkerer himself and does refurbishments and stuff on his Twitch channel sometimes too. I don't know if he does it with this one, but this is going to Sweden. And we are going to look at this one in another video where I just refurbish it and future-proof it. So I want to try to repair this one in this video. The other one is a bit complicated and would probably make this video longer than it needs to be because it got some overvoltage and there's probably a lot of broken components in there. That's going to be another video sometime. This one, the socketed ICs I checked in the working C16. It still has a black screen. So as I wrote here on this removable sticker, I suspect it might have a RAM fault. It might also be one of the logic ICs in there that's broken. Probably, maybe easy to troubleshoot. So let's have a look at that. So this one has the CPU missing because, as you saw, they break very frequently. If you happen to have an 8501 spare, I don't believe 7501s are still around that many. If you have a 7501 or a 8501 and want to part with it and donate it to me, please feel free to contact me. You can do so on my website, which is linked in below. Or in the corner there. I have a website, by the way. So these chips are all alright. So I am going to try and see if the RAM is good. These two chips, I believe. Yes, and there's some 74 supporting logic. There's one MOS 8714. This might be an MOS logic chips, and these are known to fail pretty frequently. So I'm going to look at that even closer, I guess. Okay, so let's see what we can find. Okay, I just checked the C16 again, and we actually get a picture now. So it seems to be not always black screen or blank screen. We seem to have an output there. Let's check some levels and stuff on the oscilloscope, I guess. So sorry about the mess in the lab, by the way. Yeah, that's just me. Always working on many projects simultaneously, and the lab is like, it's not very large. Let's put this to 2 volts and let's put it in DC mode, and let's bring up the time a bit. So now we should be able to see stuff on the scope. So let me just briefly turn this on. connect the ground to some ground here, and then let's just scope stuff. So the processor is alright, that's not the problem here. So I'm primarily concerned with these RAM chips and the logic chips. I need another ground there, so I can reach those. Okay. On first quick inspection with the scope, I primarily scoped around here, the logic chips and the RAM. I couldn't really see anything wrong right away. So what I'm going to do now is I just remembered actually that I burned a DIAC 264 ROM. We are going to replace this kernel with the kernel version of the DIAC 264 ROM. I'm going to link that one in below. You can make your own, or you can buy this in cartridge form, for example from the FutureOS 8-bit. They sell it. I'm going to link that in below too. You can also make your own cartridge, of course, if you have a cartridge PCB or a donor cartridge. And I found it easiest to use the ROM replacement because this does even need less working parts, I believe. Not much of an expert with this C16, as you can probably tell. I actually had to look up which one is the kernel ROM. This is the basic ROM, this is the kernel ROM. So I'm going to replace the kernel ROM with the DIAC ROM and see if that brings up the picture and tells me what's wrong with this machine. Okay, fingers crossed this works. Let's see what it does. Does it do anything at all? No, it doesn't. Okay, after wiggling around a bit and cleaning the board a bit, I got this failure mode, which is like a random blinking blocks on screen. And yeah, I don't know what that means, but it might be a RAM issue. Might also be an issue with the TAD, so I'm just going to replace the TAD again, I guess, against a known working one, see if that fixes the problem. Because the RAM is not getting hot or anything. Okay, got the other TAD in there. I don't get anything again. So here's my scope. Sorry for the arm there. And I have the machine turned on, and these just probing the pins of the RAM. So this looks pretty low actually. It should be closer to 5 volts, and this is closer to... It's actually 2 volts per division. This is less than 4 volts. This is like a normal level, that's okay. Like 4 volts. This is the supply voltage of 5 volts. Yeah, this is the normal levels. So one pin on the RAM is low. It might be the culprit. It should be around 4 or 5 volts really, and it is under 4 volts. So that might be the problem. So no idea really why it is an intermittent fault, or why it intermittently shows a picture. Maybe there's a bad connection somewhere. And what seems to be a common fault with these, and it makes sense, is that these ferrite beads short out with one another or with other components, and the capacitors are pretty wonkily inserted. Yeah, that seems to be a common issue with these boards, that they get bent and components short each other out. Or short out with the board or with other components. So that might be worth having a look at, which I briefly did. I'm going to replace the electrolytic capacitors anywhere. There's not too many on there, so it's gonna be alright. I think I'm just going to replace the RAM, because I want to put sockets in there anyway. Yep, let's do that. Using my trusty desoldering station here. Oh, and by the way, I printed out the service manual which is apart from the circuit diagram and some component lists and pinouts. It doesn't have like a troubleshooting guide or anything. It's just stuff that you would get your head around as a repair person that has a formal education in that field, which I don't have. But I'm learning, and I can read some of it. I can read schematics and stuff. So let's just see if I can find some replacement RAM for this machine in my IC stash here. Stash of ICs. I think I have some. So with a desoldering station like that, this is not such a bad thing to do. And usually I go around afterwards and wiggle the pins a bit with a screwdriver, or ideally some plastic part to not scratch or risk scratching the board. I'm just touching the pins here, and you can basically feel if they are loose. And if they are not loose, you can most of the times break the last remaining bits of solder loose by gently wiggling them. You want to do this gently because you don't want to damage the pads or you don't want to damage the traces on the board. So let's see if we can get them out. I think so. It's usually easier with these older boards. And the moment you use force for getting these ICs out, they are not properly desoldered. So you usually just have to gently wiggle them to get them out. Basically just the physical force of the legs. Look at this. This is pretty clean job of desoldering. Yeah, that went pretty well. That's nice. So let's put socket in there. I don't know if I have replacement RAM chips, but there is some tricks we can try. So I usually prefer turned pin sockets like these with the round holes, because they basically hold onto the components better. But I don't have any other this size, so I'm just using these. These are like grabbing from both sides, which is the better way of doing it. There are sockets like the ones they used here that are only contacting from one side, and yeah, that's not very good usually, obviously. But it's cheaper, so Commodore used it. So let's solder these sockets in. As a matter of fact, you can replace the 4416, or in this case 81416 chips, which are the same, with these ones that are also in later Commodore 64 models, which are 4464 chips. In fact, Commodore actually put 4464s in some later C16s because they are pin compatible, and if only the 16 kilobytes are addressed, they act as if they were only 16 kilobytes chips, basically. So I'm just going to put these in there and see if that works. At least if that changes anything. Situation here. Let's just put those in there. And that's the good thing if you have socketed chips. You can always replace them again later. Okay, testing with the RAM chips replaced. Oh ho, so I just did some cleaning on the backside of the board and removed some flux residue that was there seemingly from factory on the power switch and on some of the ports there. I believe these are hand soldered in after the board is wave soldered in like a in a wave soldering process. I'm not going to explain wave soldering now. So I reflowed some of that and removed some of the flux, and I reflowed the solder joints on the TAD and the processor. And I reinserted the DIAC 264 ROM, and look what happens. Hope I can reproduce it again. Yeah, there's a RAM test. And it seems the diagnostics is working. The kernel ROM shows up as bad because it is the diagnostics cartridge. And I don't have a keyboard connected. But at least we get a picture output now. It was just seemingly dry solder joints. That's pretty nice. It seems that this machine is now operational. There was just either a short or it skips the function ROMs because it's not a +4. The function ROMs are basically the programs that are added in the +4. Can't do the keyboard test now, but can't do the joystick test because I haven't got a joystick connected. It seems to work. It seems to work. That's nice. And obviously I don't have the sound connected. I could connect the sound, I believe. Would maybe get some sound output. Yep. There's some sound output with the graphics test. Nice. So this seems to be a working machine. Okay, let's replace the RAM chips with the old ones again, I guess. And see if those work. And the ROM. Okay, let's see if this ROM works too. Yeah, there we go. No problem at all. So the RAM was probably fine. Okay, we have wonky connections. I should redo all the joints there, I guess. I think we have wonky connections on the RAM. Maybe one or two other chips. I will definitely go over the connections there. But otherwise, this appears to be a working unit now. But yeah, another one fixed. Nice. Now I'm lacking a processor for this one. Obviously, I have to find a workaround for that. Yeah, there's still some. The sockets have some wonky connections. I have to clean this up and maybe replace the sockets even. I think I'm just going to use some contact cleaner on it and try to scrub the sockets down again. And resolder some joints. So just tried cleaning this thoroughly and it still has severe issues with contacts on the TAD socket. Don't know if I can bring up a picture. There we go. And if I touch the TAD here, yeah, there we go. I touched the socket there and it fails. So I think what I want to do is to replace the whole socket. So, and as this is a 48-pin socket, as you can see by the pin number here, 48, I'm just using, I don't have a 48-pin socket in stock, I'm just using two 24-pin sockets, which is working without problems because the pin spacing stays the same. Or at least I hope so. Yeah, look at that. That's gonna work without any issues whatsoever. Nice. Okay, there we go. Doesn't look too bad. Let's see if we can get a chip in there. Which isn't that trivial actually with that many pins, but the socket is a good one. I should be able to insert this nicely. Yes. Let's test. Okay, so that's good enough for me, I guess. I mean, this was a dirty machine in the beginning, so it probably had some contact issues there. That was the only issues this had, actually. Maybe there's some remaining issues there that I will fix. But for now, I think I'm going to call it a day. This is pretty much fixed, I guess. For now, I have 3 out of 4 working, which isn't that bad. So, yeah, thanks for watching. There's going to be more Commodore 16 videos in the near future. There's probably going to be a live stream or 2 on Twitch with my Commodore 16. If you have any games that you want me to play there, feel free to put them in the comments. If you have any other suggestions what to do with Commodore 16s, as I said, I'm not very experienced. If you have any favorite games or any favorite software you want me to take a look at, feel free to give me some hints in the comments. So much for now. Thanks for watching. Hope to see you again on this channel sometime. If you want to support me, give this video a thumbs up. That's the easiest thing. Leave me a subscription. Check out my Patreon page and my homepage, and there's also links below that you can check out for my other social or not so social media stuff. And yeah, thanks for watching. I'm Jan Beta. See you next time. Bye.